Hey PCH, let's go through an example together that really wants us to show off some of our calculator skills. And so when we're looking at the context of the problem, we see an arrow shot into the air, and we have been given a table with some values of t that represents the time that the arrow's been in the air, as well as values for the height of the arrow at each of those given times. When we're looking at some of the parts of the problem that we need to answer, it is going to be impossible for us to go through any of this without coming up with some sort of function that represents or estimates the relationship between time that the arrow is in the air and the height of the arrow at that time. And this is where we come to our regression skills. We talked about this in Unit 1, but a regression is something we can do, well, I guess more so the calculator can do, that estimates the relationship between two variables. And so the first thing we need to do in order to have the calculator come up with this equation or this function, which is part A, is we need to actually put this data into our calculator. And in order to do that, of course, turn our calculator on, we need to go to this button that says Stat. And when we click that button, we're going to see that we are on the Edit menu. And the first option that we are already highlighted on is Edit ... Let's click Enter. That's where we want to be. And what we see is we have a bunch of different lists. This is where we're going to put our data. If you already have some numbers like I do in your list, you can go up to the list header, click Clear, come on back down, and then you got rid of everything in your list. I want to put all of my t values, which for me, I'm going to keep talking about them in terms of x, and then like my values for height, those are going to represent like y values for me. Those are the values I want to put in these lists. My x values in list 1, my y values list 2. Once I have my values in my list, the calculator is going to want me to help it out a little bit, right? It's going to come up with the equation for us, but we need to give it a little bit of a push in the right direction. There are a couple of options for us in terms of what type of function or what type of regression equation the calculator can come up with. Sometimes data is going to be best modeled using a linear function. Other times it's going to be best modeled using a quadratic function. We need to tell the calculator which one we want it to do. In order for us to have a good idea of like, well, hey, this is what I think and this is why, we need to actually see these data points graphed. In order to see that, anything that I want graphed is going to, more or less show up in this y equals list in the top left corner of my calculator. But because we're talking about data points, I need to scroll up to this spot at the top of my screen that says plot 1 and press enter so that when I move away from it, it is highlighted. That is turning on my plot so I can see my data points graphed. I can press my graph button in the top right corner of my calculator and see my points. If you press graph and your points are not like beautifully centered in your window yet, the nice thing about data points is that there's a special zoom feature that will allow us to paint a perfect window for all of our data points to fit inside of. And so you would just click your zoom button, and then this 9th option is zoom stat. You would click that. So I'd click the number 9 because it's my 9th option. And that's going to put the window in a perfect spot for you to see. And when I'm looking at this data, I notice that like these data points do not follow the path of a line. We start kind of down here in the bottom left corner, and then as we move to the right, we go up, but then we start to come back down a little bit. Definitely going to best model this situation with a quadratic function. And so that's what I'm going to tell my calculator to do. In order for the calculator to run a regression, we are going to go back to that same spot where we were with our list. We're going to click Stat, except instead of on the Edit list here, we want to scroll one over to the right so that we are on Calc. Once we're on that Calc menu, we see that options 4 and options 5, linreg and quadratic reg, are like linear regression, quadratic regression. Those are going to be options that are going to help us get this, our calculator to run these regressions for us. And so I'm going to go to option 5 because we said it's quadratic. And it's going to ask us for a few things. something I did on purpose that you can see why now is I made sure I put all of my x values in list 1 and all of my y values in list 2 because that is the default that the calculator sets up when you come to your regression analysis, right? L1 is for x list, L2 is for y list. That's exactly what we did. We don't need to change anything. I'm just going to scroll right past. Also going to ignore frequency list in this example. And I do want to stop and focus on store regression equation. As I said at the beginning of this problem, we are going to need this function, this equation, to help us answer all of the rest of the problems or subparts for this problem. And so I need this equation to be somewhere that's easily accessible for me, that allows me to graph it and work with it. In order to do that, I'm going to click this VARS button, V-A-R-S. I'm going to scroll one menu to the right so that I'm on Y-VARS. And I'm going to click Enter because I'm already highlighting number 1, which is function, and that's what I want. And once I do that, I'm going to see that I just have this long list of Y1, Y2, Y3, etc. It goes on for a while. These represent spots in our Y equals menu where we can store an equation. And so I'm going to go ahead and store in Y1, that first slot. And so I'm going to click Enter, and then I can go ahead and click Calculate. Once I do that, I see it gives me the standard form of the equation of a quadratic at the top, right? Y equals ax squared plus bx plus c, as well as actual values for a, b, and c, the coefficients or constants in our equation. And so that is what we're going to write down for part A, subbing in a, b, and c for these parts of our equation. Beautiful. I have that written out here again, plugging in A for A, B for B, C for C. It makes sense. We have our equation. Now, I rounded, and that's what you need to do, right? I don't expect you to write every single digit. That's the nice part about storing our function in y equals. If I go to my y equals button, I see that this function has been put in y1 for me, which is great. I don't have to type it out, but it's gonna put it there for me, which is very nice. Let's go ahead and move on to some other parts of the question. Part B says, when does the arrow hit the ground? Now, in almost all of these examples, it's going to give us either a value for x or y, and we're going to have to find the opposite. For example, it's asking us when, as in what point in time, which is like representing t, which is my x, so I'm looking for x, when does the arrow hit the ground? Well, I don't see a number that they gave us, but what the problem is secretly doing is saying, hey, the arrow hits the ground, and that is when my height or my y value is equal to 0. Right? If I'm on the ground, my height is 0. And so it's deceptively giving you some information that you just need to think through logically and come up with that, yeah, when it's on the ground, my height is 0. And any point where my y value is 0 is on the x-axis. And so I'm going to go to my calculator. I'm going to look at the graph. And I see my function being graphed. It's a beautiful thing. And I want to look for my x-intercept. Right now, that is not showing in my window, so I'm going to adjust my window. Let's see, my x max is 5.5. Let's just say 8. We'll see if that puts it in there for us now. Great, and it will. I'm also going to give us a little bit more space below the x-axis so I have some room to work with. So we'll go like -10. Whoops, that was -1. Awkward. Okay, sorry for wasting your time. -10. And then we want to calculate our x-intercept. The nice thing about our calculator is if we're trying to calculate some key feature of our graph, whether it's like a maximum or a minimum or an x-intercept or like they give us x and they want us to find y or points of intersection, literally anything, we're going to the same place. And we want to go to this spot up here. CALC stands for calculate. In order to get there, I'm going to press the blue second button and then trace to get us to that blue word calc above this button. And I see all of these options here. I want to go to option 2 because it's looking for my 0, which is another word for x-intercept. So option 2. And then it's going to ask me a few questions to help me get there. It wants a left bound, so it just wants, it just wants some spot that's just to the left of my x-intercept. I'll go ahead and put here. I'm also going to go down below for right bound, some value to the right. And then it wants me to guess, get as close as possible to my actual x-intercept. And once I do those things, it's going to give me my 0, my x-intercept. And so, when does the arrow hit the ground? What is x when y is 0? That is going to be at 6.03 seconds. Of course, rounding to the nearest hundredth. And that is our answer. Very important we have units because we want our number to be in the context of the problem at 6.03 seconds. And we can move on. Part C. When is the arrow above a height of 46 meters? Well, again, 46 meters. That is a y value because it represents height. So it's saying, hey, when y is 46, when is our, where's our arrow at that point? And so I'm going to go to my calculator and literally graph y equals 46. When I'm given a y value, I want to graph it. Y equals 46. And when I graph, I see I'm going to have a line that cuts through my graph. And I notice that my parabola, what's in blue, which represents the path of my arrow, is above this red line, this height of 46, for a period of time. It's not just at one point in time, but it's this entire period of time that I'm highlighting with my mouse right here. And so I need to find the points of intersection between these two functions and find the x values because those are going to give me the times. And so we'll start with this point of intersection over here to the left first. Again, second trace because I want to find some key feature, and option 5 is intersect. The first question that I am asked here is, hey, what's my first curve? Which for me is, it's highlighting the parabola, which is exactly what I want. So I'm going to press enter. The second curve, the second function is my line, which is highlighting. That's great. And then it wants me to guess where the point of intersection is. So I'm going to get as close as I possibly can. And great. It gives me the x value. So I'm going to say, hey, my arrow is above a height of 46 meters from 1.36 seconds to whatever the x value is of this point of intersection. Let's find it. When I do that work, I get the x value for this point of intersection to be about 4.6 seconds. And so the arrow is above a height of 46 meters from 1.36 seconds to 4.6 seconds. Again, answering the question in the context of the problem by providing my units, and I can move forward. Part D, what is the height of the arrow? So what is y when the arrow, or after 4 seconds, which is x? If I'm given x and want to find y, it's actually very simple for me. I'm going to go to second trace again, and this first option is value. When I click that, it's going to put my cursor behind something that says x equals. Well, I say x equals 4. It's going to tell me what y is. Now, I need to make sure that it is on the function I want, which is my parabola, and that's the one it is on right now. It's going to give me that function here at the top. And so it looks like my y value, when x is 4, is about 56.85 meters. So 56.85 meters. Right, part E is saying, hey, now we have a cannon that's shot into the air, and its graph of its path is given below. And it's asking which object, either the cannon or the arrow, will reach a higher maximum height. Well, that's another key feature of our graph. We're going to use the same process that we've been using for some of these other parts. I'm going to have you answer this and then check your work here in a second. When I look at the graph of the cannon, it looks like the max height is between 70 and 80 meters. And then when I calculate the maximum, again by going to second trace, option 4 is maximum, finding the max of my arrow, looks like I get about 64 meters, and so I would say the cannon definitely reaches a higher maximum height. All right, there is another problem on the back of this page that also tests the same type of skills we just worked on. Let's go through that one and see if we can use some of the same skills to answer some of these questions.